Hello class, we're going to be going over the volume formulas that we're going to be using throughout the unit. So, there are 5 main types of solid that we're going to be using. 4 of them are pretty related, so we're going to cover them all together. First, we have a prism. You get a prism when you have 2 parallel and congruent base faces that are polygons, and straight sides. So, the base can be literally any type of polygon under the sun. It can be a weird shape as long as the other side matches it. So keep in mind, all of them are going to follow the same basic idea, which is volume is going to equal the area of its base times its height. So I did mention it with the area, is that little b means the base of a 2D shape, capital B is an area of the base face. So, just a little vocabulary. Each side is called a face. And the other h, and yes, I know they use the same letter h, lowercase, for this height as well. Still going to be height, but it is the perpendicular distance from base to base. Keep in mind, there will always be 2 base faces and then the sides connecting them. So, fun little fact, and it might be helpful if you ever have to deal with surface area. For a prism, the side faces are always going to be parallelograms. Now, cylinders are very similar. Cylinders is what happens when you say you want a prism, but instead of polygons, it's circles for bases. So you have 2 congruent and parallel circles connected with a straight side. So notice all the way around, it is smooth, it doesn't have like a bunch of mini facets here, but the area is going to work very similarly as a prism, where we're going to have volume equals pi r squared times our height. So just like when we had area, r is for our radius, and h is still going to be the same height perpendicular to the base. So one good thing is typically if it looks like it's going to be the height, it most likely is the height. They don't tend to put the diagram with the right angles, so you get a little bit of a pass there. Next up, pyramids. So again, polygon base. That comes to a point. The lateral sides are going to be triangles. So now this is where we're going to have to be a little bit careful. So similar to the prism, volume is going to equal the area of the base times the height times a third. Now, here's where it's going to get a little confusing. Remember what I mentioned? Height is always perpendicular to your base. there is something called the slant height. The slant height I'm having labeled with L. This is the height of the triangle side. It's not the base, it's not the height. If you were to look at this particular pyramid straight on, it would look like a triangle, and you'd have L. You'd have one of the sides of the base here, and the height would be in the middle. So be careful between the slant height and the height of the shape. Last, we have a cone. So it's a circular face. That ends in a point. Also, keep in mind these sides are straight. The volume for this one, same idea. So we're going to take the area of our base, which is pi r squared. We're going to take our height, and we're going to take 1/3 of it. So again, the idea of the lateral height is going to come into play again. So lateral height, do not use for volume directly. We're going to be taking care of the height itself. So notice how we have right triangles? Pythagorean theorem and trig can come into play here. So let's take a look at some examples. So where needed, I'm going to typically round probably 1 decimal place. So let's just take a look at each of these shapes and let's get started. First, we have a prism. We have a cylinder. We have a pyramid. And we have a cone. One of the first things you should do is identify where your base face is. So, taking a look at this diagram, these shapes are in the back. When you have a rectangular prism, you kind of get to choose where the height and the base is. So, I'm actually going to choose this piece here. So this is going to be my base face, and keep in mind that if that's the case, you're going to have the second one over here. One trick that I find very helpful is to have at least one of the bases colored in, just so this way I can pay more attention to what its area is. So for a prism, volume equals area of the base times height. Our base happens to be a rectangle. So, to find that area, we have 10. And we need this side. So take a look at your diagram. You want to look for anything to do with this height, and in this case, it is 4.5. Next, we have the height connecting the two base faces, which is 14. When you put all this in the calculator, you should get 630 cubic inches. So now that we're in volume, we are going to be dealing with cube powers. So if you need a little refresher, 1 dimension, this is your lines. So this is like your inches. When you make inches in 2 dimensions, you get inches squared, which is an area. And now we're dealing with actual blocks, 1 inch by 1 inch, and this is inches cubed. Alrighty, next up we have a cylinder. So our formula is volume equals pi r squared h. Because we have that, let's take a look at our circle. We need our radius. I know the diameter, so the radius is going to be half of 15, so 7.5. And our height looks like it's going to be 9. So this is just going to go in the formula. So we got pi times 7.5 squared times 8, which is 9. And So if they should ask for the volume in terms of pi, you want to write it as a fraction, so it would be 2025 over 4 pi. If they don't ask for it, then you would multiply the pi in, and you would get 1590.4 cubic meters. So all this is pretty straightforward. Okay, next up, we have a pyramid. Pyramids at least make it a little easier to find the base, because if we take a look, we have a point. The side across from that point has to be our base. Triangular pyramids are a little weird because you can make an argument that it could be any of the sides, but if they give you a height, it's best to go along with it. So our formula is volume equals 1/3 area of our base times height. Now I can already see the height here because they gave us a right angle. We got 10, the 1/3 is going to stick around, and we have a triangle. So sometimes it's easier to redraw the shape to get a better idea of what is going on. So if that's the case, we have 12, and then we have a right angle here that they are labeling for us as 7.5. So that means for our triangle, it's 1/2 times the base of the triangle, which is 12, times the height, which is 7.5. All of that goes in your calculator, and you're going to get that this is 150 cubic millimeters. Last up is the cone. So again, volume 1/3 area of our base is pi r squared times the height. So we're going to take a look. We're given a diameter again, so half of that is 4.5. The height is given directly, which is 20. And we have pi and 1/3. So again, in terms of pi, if it's asked for is 135 pi. Volume as a number is about 424.1 cubic millimeters. So these are our basics. Now let's take a look where it's a little more indirect. So now, we got our prism. Notice here, it's a little easier to see where our bases are because we have a bunch of rectangle faces, and we also have a triangle face. So again, just so this way I can see what's going on a little bit better, I'm going to shade in the top face. So this way I can tell it apart a little easier. So, because we have a triangular prism, volume is going to be area of the base times our height. So our second base is over here. The line connecting them is going to be our height. So our height in this case is 6.2. Since this is a triangle, let's figure out what this is going to look like. So I see that it is labeled as a right triangle. This far side here is 15.7. And if you look on the back part, this here is 8.5. So we need this missing side in order to find our area. So we have two sides in a right triangle. Pythagorean theorem is going to be the move. So we're going to have a squared, which is 15.7, plus b squared equals 8.5 squared. Actually, no. So remember, hypotenuse is always your c. Hypotenuse is this one here. So make sure not to get them confused, otherwise there will be errors. So we're going to get b squared by itself, which is 15.7 squared minus 8.5 squared. We're going to square root both sides. And I'm pretty sure this is not going to be the greatest number, so I'm just going to leave b as the square root of 15.7 squared minus 8.5 squared. So now we plug this into our formula of 1/2 our little base is that square root that I'm not going to rewrite right now, and our height of the prism, sorry, this is triangle height, so times 8.5, and then we have the height of our prism, which is 6.2. So you're going to type the whole thing in the calculator, and you're going to get 347.81, so 82 cubic yards. Next up, we have a cylinder. So our base face is going to be the circle. So on our circle, we're going to want a radius. Obviously, we don't currently have one. So we're going to have to get a little creative. So if we take a look, there's a little triangle. If we go from here through the diameter and through this height, and because it's the height of the cylinder, we know there's a right angle there. So again, we have an example of Pythagorean theorem. I'm going to call this b squared. So b squared plus 9.5 squared equals 19.3 squared, because this is our hypotenuse. B squared equals 19.3 squared minus 9.5 squared. Take the square root of both sides. And again, I'm going to leave it like this. So we have volume equals pi r squared h. Got pi. Now our radius is going to be this number here squared. So we're gonna have 19.3 squared minus 9.5 squared. All of that is going to be over 2. So when the 2 gets squared, it's going to become 4 times 9.5. So all of this goes in your calculator. So let's type that up. So now we currently have, let's see, let's ignore that. We have 19.3 squared minus 9.5 squared times 9.5 divided by 4. We're going to multiply that by pi. And we are going to get 2,105.9 cubic meters. So just as a reminder, guys, be very careful. Common mistakes here are forgetting that once you find B, you have to split it in half for the formula, as well as that square, super important. If anyone's confused where I got the upper term from, if we have B squared, we know what R squared is, or diameter squared, I should say. from there, cut in half. So let's take a look at our pyramid. So, pyramid problem, we're finding volume. So volume is equal to 1/3 area of the base times the height. Base is going to be pretty easy to see, which is this square on the bottom. I will say, if it helps, sometimes it's good to draw the other views of the shape. So we have our base, which is 28 by 28. And we'll also take a look, if we were staring at this straight on, I would see a triangle, which actually, let me trace it a little clearer. So from the tip down here, we go straight across and end up here. So this, we know the bottom part is 28. We know the side height or slant height is 22.1. What we need to find is the actual height, this. And just to draw it in here too, we need to find that piece. So first, area of our base is 28 times 28. Now for the height, we're going to use the Pythagorean theorem again. So let's take a look. Because this is a pyramid, in most cases you're going to assume that all the sides are going to be following the same angle. You could have a slanted pyramid, but it doesn't show up quite as often. So let's take a look. If this is an isosceles triangle, each half is 12. So Pythagorean theorem is going to say that our hypotenuse, which is 22.1 squared, equals our base, which is 12 squared, plus our height squared. So our height is just going to be 22.1 squared minus 14 squared. We're going to take the square root of both sides. Our height is 17.1. Just going to type that over here. Type all of that in the calculator, and you're going to get a volume of 161.2 cubic millimeters. Technically, it's short enough you don't have to really round it, and it would be 196 cubic meters. So either way will work. Last type of question is with the cone. So we're still going to have our volume equals 1/3 pi r squared h. We have our base face, which is the circle over here. So now you just have to figure out what our information is. Well, first, on the bottom face, we have 10.4 is the diameter, so we know for sure that each side is 5.2. So our radius is 5.2. Now we're going to square it. Now we need to figure out our height. So just like before, if I were to look at this straight on, I would see a regular triangle. So let me just redraw over here. Again, they didn't give us any indicator that it would be a slanted cone, so we're going to treat it like it would be just straight up. So we have 17.3, and on the bottom face, we still have the 10.4. Because our height is going to go from here down to the center. So again, isosceles triangle, because this is not a slanty cone. This is an altitude, So that means this is also split up, so we got 5.2. So we're going to need Pythagorean theorem again. And we are going to have a squared plus b squared equals c squared. 5.2 squared plus b squared equals 17.3 squared. B squared equals, let's see, square root of 17.3 squared minus 5.2 squared. B is going to equal 16.5. Okay, not a bad number. So we're going to plug it in. Type all of this in the calculator and you should get 467.2 cubic centimeters. This is squared. So, for your reflection, I want you to take a moment and think about how can you tell the difference between the different heights? How do you tell them apart? So the three heights we talked about here is the height of the base, the height of a prism, or really the height of any solid, and the lateral height. Or if you prefer instead, this is also called the slant height. It is really easy to get them mixed up, so you want to make sure you have a system in place for telling them apart. And aside from the three different heights, what parts of volume do you seem to be confused about, if any? If so, jot it down and we can answer it in class. And with that, that is the introduction to volume.